Okay, I think we have left a couple of minutes, 2.5 minutes, and everyone's busy. So I think what we're going to do is make a start. Now, unfortunately, the computer where I do my processing means that you get to look at the side of my head while I'm looking at the main screen. So just before we kick off, a few things. What we're going to talk about is scaling from inherent scaling without the use of constraints, scale bars, or ground control points or camera positions, anything like that. What we are looking at is getting scaling from a 3D model without any post effort. When I say post effort, by means of having to add things like markers, ground control points, scale bars, and forcing the camera bundle to adjust on those conditions. What we will be working with are things like this, where I've got two DSLRs, they're synced to fire together, and you simply shoot the model as if you're shooting with a single camera, but with two cameras. And the key thing is the fixed distance between the two centers is known and stable. Then what you get is a scaled 3D model for your trouble. Obviously, for terrestrial applications, this is useful because you can just walk around the building or the subject or whatever, and you get a scale model. But for people that work underwater, for us, is one of the changes. We've got quite a few clients working with stereoscopic cameras in the oil and gas field and world, but those cameras are like £125,000. So what we've done is started to develop cheaper, more cost-effective alternatives. And it's not a new technique, it's been around a while, but we think there's a real sweet spot now of software capability and camera capability and cost, obviously. That means we can go out and shoot scale models underwater where we will not need to put any constraints or scale bars or tape measures or carry anything like that. Just go down and shoot the model and come back and know that it's accurately constrained. So there's a few things to think about when you're working in this way. And the first thing is to think about how you organize your images. And you can see here that they need to be grouped into left-hand camera, right-hand camera. So all of these images are coming from the left hand. All of these are coming from the right hand. And crucially, they need to be the same number of images between each folder. If you have a variation, you've got one difference, the software is clever enough to realize that you are trying to do something else other than work with stereo cameras, and it will just say, fine, I'm going to carry on and do it ordinary and not allow you to put constraints in. So there's like a detection. If you're expecting to do 3D reconstruction with stereo cameras and the software doesn't ask you the question, do you want to link these folders? There's a flag there to say something's gone wrong. Now, the other thing as well that you need to consider is the synchronization of the cameras. They need to be, depending on how fast you're moving, synced either within milliseconds if you're moving quickly, or if you're moving very, very slowly, you could sync at maybe 1 second, 2 seconds. You know, if there's something that is really static, you could sync the camera once an hour if you really wanted to. But the key thing is to fire the cameras at the same time. If you imagine you've got the problem where you shoot one image and then move slightly and shoot another image, the stereo cameras are having a slightly different view of the world based on their position, and you lose the ability to constrain it. And that is a problem, but we've solved it, and we've solved it for underwater use as well. So the good news is that once that rig is built, I'll be jumping in a quarry and eventually the sea to test it, maybe as soon as not next week, the week after should be good for testing. So in Zephyr, I will say that all of this is covered, what we're talking about, all of this is covered in our training materials, our online course. And that it's true for both Zephyr, 3DF Zephyr, and for Agisoft Metashape. Both software applications can comfortably manage and work with stereo pair cameras, or indeed multiple cameras. I should add that right now there is a vessel currently on station. I think they're on station or they're transiting to There's a little wreck in the North Sea called the Titanic, and a camera rig, a 3-camera array that Jose has designed, is on an ROV that is scanning the model in 3D and at a super high resolution. So this is the kind of application where we find ourselves being asked to do things. Is how do you organize the cameras? What's the most optimum way of doing it? There is a science and an art behind it. I seek Jose's guidance on that because Jose's better at it than me. But basically, if you come to us with a camera and a lens combination, you say, oh, you want to work in pairs, triples, or maybe even 6, we can design it for you, build it for you, and do the layout so that then the cameras work optimally. So when you arrive here, what you get is a workflow. And I'm just going to create a new 3D project in Zephyr. Now, Zephyr does have a very sort of simple, straightforward workflow to run through. It's a little bit like Metashape, but it's more guided. And one of the options we have down here is set up multiple camera groups. And we want that checked on because we know we are expecting paired cameras, paired images. So we say next, we select the folder, which is the owning folder of both the left-hand and the right-hand cameras. And it asks us here, would you like to include all the subdirectories? Well, yes, please, I would, because there's 2 folders and they've both got images that we need. And then next, and then we're prompted again. Looks like the images are grouped in 2, because this is the point now that we add that constraint in, the thing that makes it all work as a scale. And we've got a choice of translation and rotation. We're going to use distance and rotation. And what we do is set up a distance now. And this is the distance between the centers of the cameras. I'm just going to turn back to our training course because, believe it or not, I don't remember what I wrote. But I have got it here, and I will just get the number out of it. There it is. Okay, so this is all part of our training course. And this is a data set that we offer for download if you don't have a set. So if you want to learn and work with a sample, it's all there ready for you. And the distance we want is 0.284 of a meter. And the other thing we're going to do is just tweak the accuracy here. This accuracy is used to help the software understand how close we think that value is. If we do a really tight value, sometimes we can lose cameras because if that value that we measured isn't as accurate as we like to think it is, we can see it drop cameras. So we'll go for 7 millimeters. What we're saying is we think that 284 values within 7 mil. We can add it in rotation as well here, alpha, beta, and kappa, but we don't need to. The camera's sensors were parallel at the time. Now, a note on that is that not every camera setup works well with parallel sensors or perfectly aligned sensors. The stuff that's going to the Titanic has been specifically calculated to angle inwards. And there's one important thing to remember. If you see people working with multiple camera arrays like GoPros on a stick or something like that, it doesn't necessarily mean they're creating scaled models. What they might be doing is getting more coverage, covering a larger area with a single pass with more than one camera. And the intention here is not to do that. The intention is to really extract the value of 2 cameras and have this scaling as inherent. And that's what we've set here, 0.284. So if we say next on that, we then get the calibration values for the camera body and lens combination, so that Zephyr understands how the light transmitted through the lens and camera. We're going to use the default. We'll just use the default reconstruction values. For those of you who don't work with Zephyr, these presets are really quite useful. If you want to go into detail, go advanced, you can tweak this stuff. I started tweaking it and then I've just reverted to using the defaults because they just work well. You know, these options are available, but unless you've got something really compromised or perhaps less than ideal from your data set, you probably don't need them. Okay, so we'll say next on that, and we're going to use all 72 cameras, so that's 31 cameras for each individual camera body, and we'll just run it. And what it's doing now is working through the key points, and I will just have a look and see if there's any questions. If there are any questions, please raise your hand. There's no questions in the chat so far. Please type away, let us know. It won't take long. I've deliberately chosen a small data set because it will. It's a little point of a waste of time, I think, if you've got 1,000 image data set while everybody watches the same process that can be achieved in just 30 frames, on this case 72 frames. That's nearly done. I do apologise if there's trouble with the sound. Should be connected okay. Hopefully it's all right. And as long as you can hear me and get the content across, then I apologise for the robotic nature. Yeah. Okay. So we're finished. Every camera is aligned, and if we finish on that, we can start to see there is a sparse cloud starting to appear. And this is one of our training packages. So what I'm going to do now is just do a little validation. There is a scale bar in here. If we have a look at one of the pictures, for example, there we can see one of the scale bars there. So we've got a known distance in this scene, which is pretty much best practice, really. So what I'm going to do is add a control point, and I'm going to choose this one here. I'm just going to drop a marker down and then automatically find the rest. And it's found, let me see, found quite a few, that's good. The error is a little bit higher. I would normally work on this and just tweak it. But in this example, I'm just going to say that that's fine. We're not here to test the placement of markers. We're more interested in how do we validate and how do we create this work. So I'm just going to create another one. Come over here and we can grab that one. Just drop that there. There we go. And just do an automatic detection on the rest. Again, that's actually not bad. 1 pixel, yeah, that's all right. I'll live with that. So then we'll say okay to that. And the reason I've put these markers in really is only now so that I can create a very quick polyline that runs between the two. And this polyline, all I'm doing is then being able to measure it to say what is the distance, and the actual distance is 0.250, so 250 millimeters, quarter of a meter, and the model thinks that that is 251.2 millimeters. So 1 millimeter error. I would argue that 1 millimeter error is probably within the tolerance that you could expect, because the resolution of the pixels in that image is probably close to 1 millimeter per pixel. So within 1 millimeter, I'm more than happy. And so at that point, I'm just going to run into the 3D model generation and create a very quick surface. Again, what we have are presets, and if you really want to, you can go into the advanced in Zephyr, change them, tweak them, get a slightly different result. These days, like I say, I normally run on the defaults. I think you're probably right. It was a typo. I can go back and check it later. The course material that's right in front of me does actually say 7 centimeters. I'm going to go away. I will have a little question of myself and what I wrote there. So it's always good to have a second pair of eyes saying, are you sure about that? So there we go. Any other questions? Please do speak up. No, all good. Okay. It's nearly finished doing the point cloud. and it will shortly do the surface. Just while we're waiting, just to remind everybody, the cameras have to be synced. The distances between the centers of the cameras or the centers of the sensors need to be known and understood. And the key thing to remember is we're not using this wide lens coverage to cover more area quicker. We are using this as a stereo pair to work together with that distance between the two to make it scaled and to be able to then feed that data into either Zephyr or Metashape and process it accordingly to give us that scaled 3D model. You may have noticed right at the beginning of the workflow in Zephyr that there is an option to say, go ahead and create me a mesh, go ahead and create me a textured mesh. You can even generate an ortho photo as well if you want. The benefits of that is you can set your cameras up, set your scale up, and just churn out a model at the end of it, and then check the model, validate the model, as we all should, prior to using it downstream. But it takes away some of that manual work in between the two. And in areas where GPS is denied, for example, and we do work in those areas, underwater being one of them, although we do have UIS, we're generally GPS denied there. And as Rollo has just raised the question, how would you apply this technique to linear projects such as railway tunnel? Well, the answer is just as you would with photogrammetry, but use two cameras. The two cameras then aren't dependent on any ground control points or any GPS. There's no requirement for that. We have quoted for a tunnel job to actually do the vertical shaft in a tunnel using stereo cameras, and we haven't heard back yet on that. But the idea is that you can generate something that is scaled and accurate very quickly with scaled cameras. That's really the advantage of this technique. So it's finished, and if I click on finish, we can have a look. You will see part of my drive out the house, front of the house. This is just the mesh. This is it's a colored mesh. It is not the textured mesh that you'd expect, but this is the object that was scanned. 72 images all paired, so 31 in total. And if we use the rough sort of arbitrary measurement, we can then measure anything we like. So if we measure from here across to here, for example, 0.5018 meters, this is actually a 21-inch torpedo bulkhead. I think 21 inches is close to that. This fits inside the torpedo, so it's slightly under 21 inches. So we're pretty confident because we've got this scaling in here. These points and these distances are in no way constraining anything. They're not actually asserting any control over it. And if we go and have a look at that just to prove it's not smoke and mirrors, if we look here, you can see the control points, GCP1, GCP2. They've got no CS is control, CK is check. They're not asserting anything. There's no value assigned to them. We are just scaling from the two cameras that was used. And that's kind of it with this. It isn't complex. The more complex area is the design of the camera array, in my view. If you've got a robust and rigid system to hold your cameras together, you can work quite comfortably with this way. And there is then the choice of how do we arrange the cameras? What is the pitch between the cameras? What is the angle of the sensors? Jose will talk endlessly about how we could spend